So here is pulled out. There's Dry Falls that I was just showing you that area a second ago. Here's Spokane, and this is glacial Lake Missoula, where they can figure out how deep the water went by looking at the size of the sides of the cliffs. They can see splash marks and stuff. So here's where the ice dam was, and when it broke, these areas. Can you see the gray areas? That's where the water ran through. In the Wallula Gap. Here, this area, this narrow channel it had to flow through, would have been 1,000 feet deep as it got backed up. More water, when the peak of this running, more water was running through across eastern Washington, what is now eastern Washington. It is flowing on all the rivers and streams and creeks in the world. If you take all the water that is right at this moment flowing down a river, down a creek, down a stream, more water would have been flowing across eastern Washington for a period of several weeks. Once that dam broke, it would have been just gushing across, and it carved out the Columbia River.
Back to Google Earth again, zooming in on eastern Washington, looking at the Google Earth. Look at that pattern right there in eastern Washington. Here's where the dam broke, and here's where the water all gushed. And here's like Spokane, the water would have gone right around either side. And you can see the tracks of the water. This is from, we're talking about 15,000 years ago. And you can still see the tracks of the water as it gushed across the state. And wherever it gushed, it left these very distinctive kind of marks. You could pick a spot at random. You're not going to find terrain like this anywhere else in the entire world, because this was defined by the water gushing across it at a rate that has never happened anywhere else on the planet. So like I said, a view from space, you can still see the leftover tracks of the whole eastern Washington where that water went.
So Dry Falls, I was mentioning it before. I showed you on the Google slides, was the largest waterfall ever to exist on Earth. It was 3.5 miles wide and 400 feet in height. And now compared to Niagara, Niagara is 1 mile wide and 177 feet in height, right? So it's like, oh, Niagara is so huge. Well, Dry Falls was way, way bigger. But it ran only for a short amount of time, thousands of years ago, and then it would dry up. But for a few weeks, more water was flowing over Dry Falls than now flows through all the rivers in the world. And now I want to get to the question of what good does any of this unique geology do us? And the answer is tons. It really benefits Washington State to have this unique geology because, okay, here's a picture of the Columbia flood basalts. The tan color is where the basalt layers are, and it got chewed out, making these coulees, they're called, these gouged out, these river channels. You know what these pink things are? What are these pink things? Those are dams. Okay, let's look at Google Earth again. Okay, here's Google Earth, as you probably recognize by now. And if you zoom in, remember how it's weird? It's got all these channeled scablands, but look at these green areas, these circles. What's going on with these circles? That's agriculture. That's the green area where you're growing crops. Washington State, most of Washington State's crops are grown in eastern Washington. Agriculture is a huge part of the economic, strength of Washington State. Here in Western Washington, we have things like Microsoft and Amazon and Boeing. In Eastern Washington, not so much. A little bit of industry, but mostly agriculture. And that is all made possible by irrigation. And that's what the dam system also does. It makes the irrigation possible, to make the agriculture possible. And so all these crops are grown because of the dams that we have in the Columbia River. And those are possible because of the coulees carved out by the Megaflood. Okay, they're perfect for running water to go through because they were carved out by enormous amounts of water, running water. And so this is where the agricultural areas are. Now, why are they circular? We'll get to that in just one sec. Okay, coulees, that is those channeled areas carved out by the Megaflood, allow irrigation for agriculture. And again, you can kind of see those circles a little. This is taken from an airplane instead of Google Earth. If you need more time to write that down, go ahead and pause it. This is why they're circular. This is what the sprinkler system looks like. They're on wheels and they got a central hub, and it kind of goes round and round and round, slowly moving over the course. I don't know how many hours it takes to do one lap, but meanwhile, it's got the sprinklers sprinkling the water. So it's artificial rainfall coming from the rivers, powered by the electricity produced by the dams as well. Okay, so the dam system is an agriculture system, an irrigation system. Grand Coulee Dam is one of the main ones that powers the whole thing. Now, Eastern Washington climate. What's it like in Eastern Washington? In Western Washington, we have things like rainforest. In Eastern Washington, they have desert. Okay? Now, this is something that's in climate about rain shadow, it's called. As the water goes across the mountains, it gets elevated, and that makes the water condense, so all the humidity rains out of it. And when it comes back down the other side, there's no water left. Okay? And so that's called the rain shadow. So we have a desert in Eastern Washington. If you look at rainfall here, this is the largest rainforest in continental United States in the Olympic Mountains there. 180 inches or more of rainfall. And then here's the Cascades, and then under 10 inches. It's a desert over there. And yet, what do you have? Washington State agriculture is mostly in Eastern Washington. Apples. We are #1 producer in the country of apples. We produce a lot of milk, wheat, potatoes, cattle, hay, nursery, greenhouse, cherry. Hops is what you make beer out of. Grapes, make wine out of. All these things are grown in Eastern Washington. But the coulees, of what those are the channels that were carved out by the Megaflood. And so the Grand Coulee was like one of the biggest ones. So the coulees cut out by the Megaflood make our dam system possible, our hydroelectric system. They make it possible. Now, here's the thing about the hydroelectric in Washington State. A lot of people don't realize this. I mean, I know I've told you in class that we have hydroelectric. But the United States, U.S. electric power generation, is mostly, well, almost half, 49.61, coal. Coal is the dirtiest form of energy production. It produces a lot of carbon dioxide and a lot of soot, right? Very inefficient. Natural gas is also a fossil fuel, makes CO2, but it's cleaner than coal at least. Nuclear is 19.28, which is clean. It doesn't produce fossil fuel emissions, and so it's not a greenhouse gas producing, but the disposal of the nuclear waste is always a problem. And you get hydroelectric, 6.5%. That's the blue area. So United States, all the burning of coal, fossil fuels, right? This is all fossil fuels. And of course, that produces greenhouse gases and only this much hydro. You also have a little bit of solar and stuff like that. 77% of Washington's electricity is generated by hydroelectric power. So if you take that pie chart, and here's Washington State, that's hydroelectric. We get most of our energy through hydropower. And that means we're not making as many greenhouse gases, not contributed to climate change as much. Write that down. If you didn't have time, rewind and pause. Now check this out. Look at this slide. Can you read it? Again, I sure hope you're looking at this through a decent sized screen instead of like a telephone screen or something. You get all the states of the union and how much hydropower they have. Rhode Island, Delaware, nothing. 0. Now, the color code, feasible means, it could be made into it. Excluded means, well, you can't because there's like a national park there. Developed is real, how much is actually made into hydroelectric power. Oh, look, Alabama has a little bit, that much. Arizona has a little bit, that much, the little green area. And then you get boom, Washington State, right there. That's Washington State, the green line. Compared to the next one is California. Most of the hydroelectric power in our country is produced in Washington State. So this bit about hydroelectric power in Washington, we are unique that way. And the reason we have so much is because we have that Eastern Washington geology where you had the flat area with the basalt and then the mega flood ran over it and carved out these coulees that are perfect for making hydroelectric power. Now, yes, there are drawbacks to hydroelectric, like salmon habitat. It's hard for them to swim back upstream, but still, I think that's something we can be proud of.